In this segment, we'll add a ratings systems to our bakery database, starting a new Bakery 2 database, and we'll introduce a diagramming approach for tracking database tables and their relationships. Now, the new version of our bakery database, Bakery 2, adds 2 new features with new tables to support them. In this segment, we'll add a ratings system that lets customers offer a numeric rating and comment on a product. And in the next segment, we'll add discounts, in which certain products are offered at a percentage discount for a period of time. The ratings feature requires 1 new table, and the discount feature requires 2. The existing 4 tables of bakery are hard enough to keep track of, and especially with all their foreign key connections. When we add 3 more, it'll be even harder, especially since the inter-table relationships will get more complex and numerous, more than doubling from the current 3 primary key to foreign key connections to a total of 7. So let's look at a method to help visualize database tables and their relationships. And this is an entity relationship diagram, or ER diagram, or just ERD. And here's an example for Bakery 1. As you can see, the diagram shows each table as a rectangle with a title bar giving its name, and beneath that a list of its columns. For now, ignore the types like var, car. We'll cover those later. This particular diagram was built automatically by Workbench's database reverse engineer menu option, and you can try that if you like. And this includes details that we don't need at this point. For instance, the indexes drop down here is another thing to ignore for the time being. In general, ER diagrams needn't be this SQL syntax heavy. It's common merely to name the table and list the columns, perhaps with a general indication of their type like int or string. The essential ingredients are the tables and the relationships between them. And those relationships are indicated in our diagram by dashed lines, with one end anchored by a circle and the other branching like a little river delta. Those 2 symbols indicate a one-to-many or one-to-n relationship, where one row of table A, for instance customer, links with possibly many rows of table B, for instance receipt. And this is done via a foreign key from table B back to table A, customer ID, for instance. In Bakery 1, many receipts may link to one customer via foreign key customer ID. Many line items may link to one receipt via foreign key receipt ID. And many line items may link to one product via foreign key product ID. And as you can see in the ER diagram, there is a symbol for each of those relationships, with the many side marked by the river delta end of the line, and the one side marked by the anchoring circle. Now, the particular symbol varies per ER notation. Some diagrams use a simple line with ends labeled 1 and n instead of with a circle and river delta, but the principle is the same, regardless of notation. There are many cases in a database where many rows of one table link with one row of another, and an ER diagram labels such situations as 1 to n relationships. 1 to n relationships are the most common, but there are other possibilities. We'll see shortly an example of an n to m relationship, where one row of table A links with many rows of table B, and vice versa. And in some cases, you'll see a 1-to-1 relationship, where rows in a table B link via foreign key to rows in table A, but with at most one row in table B linking to any one row in table A. Often the table B row supplies optional extra information to add to the data in the table A row that it links to. We'll see an example of that a few lectures hence. And in the interests of full disclosure, the term ER diagram is widely used to describe diagrams just like the one I showed you here, but like so much else in this field, ER diagrams have a purely theoretical definition, which this diagram and most ERDs used in practice don't follow strictly. And here's an example drawn quickly off the internet to show you what I mean. This is clearly a lot more abstract. We may look at this more abstract form of ER diagram later in this course, And you will encounter it in more advanced database courses as well. But for now, we'll stick with the nice concrete approach. Now, at this point, please load bakery2 by running bakery2.sql. And let's look at its new tables. I've got it loaded up here. So first, we have a new table for customer ratings of products called rating. There. Each row in rating has foreign key links to a customer and a product, along with a 1 to 10 numerical score and a comment. Like that. So question 1, write a quick query that lists all products, give their kind and flavor, with a score of 10 by any customer, and repeat each product only once, adding a column to the select if and only if needed. You'll need a join, and you should get 2 results. So the answer here is that, as you can see, there is a link from the rating to the product. So we wanted to select a distinct product ID, because kind and flavor can be duplicated across products, from product and rating, where the product ID equals ID and rating score is 10. And there are our 2 results. Now, question 2. Before we do more queries on rating, augment the ER diagram to show rating and any new relationships that it introduces. You should end up with a new rectangle and a couple of new relationships. And the answer here is that we need to add the rating table and 2 one-to-n relationships with rating on the many end of each. 1 to customer and then 1 to product. Now, let's try building a more sophisticated query than any we've done so far. Let's list all cases where a customer has bought a product and rated it well, and we'll do it in phases. So question 3. For the first phase, write a query that lists each product that any customer has given a score higher than 7. Give the customer's first and last name, the score, and the product flavor and kind. Repeat the same customer for every score higher than 7 that they gave. There's no need for distinct, not yet. And don't worry yet about whether the customer actually bought the product. Just check for ratings over 7. You should end up with 7 rows. So what we need to do for this is select the first name, last name, score, flavor, kind, the 5 things asked for, and a link between customer, rating, and product with the necessary where clauses, and then a score of 7. And there's our 7 rows. Now add sorting by score in descending order, and secondarily by customer, last, and first name in ascending order. The combination of ascending and descending order in that sort will require a bit of lookup and experimentation with multi-key sorting and the DESC keyword that we saw earlier, and so forth. So that is a modest research project. Okay, what you should come up with is something like this. We're adding order by score DESC, last name, first name, and note in particular that the DESC modifier can be applied individually to each sorting key. So this query does sort in descending score order, but in increasing order, or ascending order, of names within the same score. So Rupert and Travis Esposita, in particular, will appear in ascending name order within the group that gives a score of 9. Okay, so on to question 5. Now try listing instead for each customer all the products they bought, giving last name, first name, kind, and flavor. Repeat the same customer if they bought several products, but don't repeat the same customer and product combination twice. Add columns to the select if you need to avoid that repetition, and you should get 385 rows out of this. I came up with something like the following here. To avoid repetition of customer and product combinations, we need distinct. But because two customers may have the same first and last name, and two products may have the same kind and flavor, we must add the disambiguating ID columns for both customer and product. And there is our 385 rows. Now, combine the queries for question 3 and question 5 to list all products that each customer rated over 7 and actually bought, giving first name, last name, score, kind, and flavor, and use the same ordering, by the way, as for question 4. Avoid repetitions of the same customer and product combination, adding columns as needed to do this. And this will require a join on all 5 tables of Bakery 2, and you should get just 4 rows. So, after what may have been a bit of work to figure all that out, what you should come up with is something like this. There's our select of the material needed, and there's the 5 tables with all of the foreign key, primary key linkups necessary in various points in the where clause, specifying also that the score is greater than 7, and then there's our order by, as we had in question 4. Now, there are the 4 result rows. This is a fairly sophisticated multi-join query. And note the method we used to build it. We started with simple queries and then extended and merged them to arrive at a more complex query. Until you're more accustomed to SQL, this approach is strongly recommended. Don't just write a huge query from scratch. Build it incrementally so you can debug and experiment as you go.